We will now begin today's session. First of all, thank you for attending the third Workspace Live Code-along. A huge thank you as well to the speaker, Ramnath Vaidyanathan, who together with DataCamp and especially all of you made this event possible. So we shared the link again to the template that you will be using. So in case it's not working, try opening it again, and you might need to create a DataCamp free account, so not a business account. So make sure that you log in with a DataCamp personal account, and that might resolve it. So next slide, please. So a little bit about DataCamp itself. Our mission statement is to democratize data science education and make data literacy accessible to millions of people and businesses around the world through our learning platforms and now our practice through workspace, certification, and events such as these. Next slide, please. Our speaker for today is Ramnath Vaidyanathan. He is the VP of Product Research here at DataCamp, where he drives product innovation and data-driven development. He has over 10 years experience doing statistical modeling, machine learning, analytics, and making interactive visualization. So yeah, you name it, he's done it, and I can assure you that you're in good hands. Next slide, please. Today's code-along is divided into several parts. First, Ramnath will solve the first challenge of the template, and this will be followed by a Q&A. And this part should take about 40 minutes. And then next up, he will do the second challenge, and we'll have a Q&A for that as well. I'll let you know that to put your questions in, you can access the question button on the control panel of GoToWebinar. And finally, Ramnath will give some closing remarks about the template, and I will say some words as well. And the whole session should take about an hour and 15 minutes. Next slide, please. So yeah, we want to remind everyone that the session is recorded and the link will be posted along with the solutions later on Slack, email, and other social media platforms. So thank you for your attention, and now into the event itself. Over to you, Ramnath.
Thanks, Yash, and thanks everyone who's there in this code along. So you should have the template by now, and the template basically should if you open the template up, you should open this notebook in Jupyter Lab, and basically this is what we'll be using. The solutions will be shared later. So yeah, so please watch carefully, and if you get stuck, please put it out in the chat. Try to see if you can help debug stuff. So a little bit about DataCamp Workspace before we get started. So the best way to think about DataCamp Workspace is it is your data science IDE on the cloud, right? So some of you would have been using Jupyter Lab locally, and this is basically just taking it to the cloud. Lots of advantages. I mean, you can essentially spin it up quickly. The dependencies are all in there. Then Workspace also allows you to publish. We'll kind of go through that. So once you finish an analysis, you can share it. You can click on it, and you can publish it, share it with people. So there are a ton of advantages in terms of doing things in the cloud, and the whole goal of DataCamp Workspace is to basically provide you with a really good experience doing data science in the cloud. And for those of you who have done projects, you might have already discovered it. If not, I would definitely recommend going and checking this. For a completed project, you will be able to open it in Workspace, and that is a really cool way to use what you've already done and build on top of it, so that you can build a nice portfolio. And talking about portfolio, yeah, so once you start publishing your data science articles, it'll show up in your profile, and so the profile is something that you can actually share with people, and I mean, you can use it as a blog as well, right? So this is kind of Workspace, DataCamp Workspace in a nutshell. If you haven't already checked it out, please check it out. We are trying every day to improve the experience, and any feedback that you have will be important as we kind of make this journey forward. So with that introduction, let me get started with the topic of the day. So the best way to learn data visualization, once you have the basic concepts in place, is to just look at some of the great visualizations out there and try to recreate it, right? The advantage of recreating is that you really don't have to think through the design decisions because they've been made for you already. So it allows you to really focus on how will you implement it, right, by using the packages that you already know. So I find it really useful to do it that way, because otherwise you're thinking about the design of the visualization and the actual visualization at the same time, which eventually you'll have to, but this is a good step in between where you say, okay, I know what I need to do, now let me just go and do it, right? So the purpose of this code along is going to be twofold. We will recreate two visualizations, both from the New York Times, which is one of the best places for a lot of visualizations. We'll recreate two of them. And the second goal I have is, like, while recreating it, I also want to take you through the process of how to think about the visualization, right? Once you have an idea of what it's going to look like, how do you think about it, right? And I'm hoping that this will like let you recreate these visualizations, but also like give you enough to be able to take these ideas and apply it to other visualizations that you see out there. Okay, so that's the goal. So having set the context, let us get started. So as usual, I mean, we're going to load a couple of modules. So we're loading the pandas module as PD. We're loading matplotlib as pyplot as PLT. And this is a setting that some of you might be familiar with. It's a very useful one. Basically, what it's saying, it's a configuration setting in JupyterLab. And you're saying that, okay, hey, I want the figure to be rendered in the Retina format, which is a higher resolution format. So if you want better figures, I would strongly recommend turning this on. And I can show you like what happens if you don't turn it on. Finally, we are also importing Seaborn here. We're not going to be using Seaborn in this code along, but for those of you who are looking at recreating it with Seaborn, I mean, this directive, this import statement is there so that you can use that. So let me just get more screen space here. So I'm going to run this piece of code, and all that it does is it loads the modules. So now let's look at the visualization itself and really try to understand what this visualization is doing here. So this was actually published in 2012, and an interesting backstory to this is like this visualization has a personal connection to me. Like this is one of the very first visualizations that I recreated in my journey to sort of becoming a data scientist. So yeah, it holds a special place for me, and that's one of the reasons I chose it for this code along. So what does this visualization exactly do, right? So it basically plots a metric called strikeouts. So if you're big into baseball, then you will know what this means. But for those of you not into baseball, don't worry. It's basically just a measure, strikeouts. And what this visualization does is basically plots. If you look at the blue line is essentially the strikeouts per game for the entire league. And the key point is that, yeah, the strikeouts kind of are on the rise. And this is 2012. We will see what happens beyond 2012 because we have more data now, right? But a couple of other interesting things in the plot. It doesn't really just show that. It also adds a couple of other elements, right? So one, for example, you'll see this orange line here. The orange line is the strikeouts per game for a particular team, right? So in this case, I mean, the San Francisco Giants. So that's another layer. And finally, you also see all these dots, right? And if you think about what these dots actually mean, these dots are the strikeouts per game for every single team in that year. So that's why you see multiple points per year, right? And it's a really nice way to kind of combine information. And so that's the third one. And finally, you also see that there is useful annotation on the plot that shows, for example, okay, that 1969, what exactly happened, right? And it's very useful because it gives context to your reader that, I mean, they may not have, right? And this reminds them, okay, so if you're looking at a data point, like, please think about what happened. So that could explain everything, okay? And finally, it also sort of, I would say, points out a couple of interesting points on the plot, right, calls attention. And that's kind of useful because basically when you create a visualization for communicating an insight, it's really important that you direct the user towards that conclusion, right? And effectively everything that's in the plot together does the job for the reader. So and so the reason I deconstructed this plot is because we will be reconstructing this plot using the same logic, right? We will create the line first, then we will create the orange line, then we'll create the gray dots, then we'll create the text annotations, and if time permits, we will create these extra annotations about the points. Okay, so so let's now figure out. So first, so we need data, right? We need data to do this, and so the data has already been provided for you. It's actually a excellent database compiled by Sean Lemon. There is a link in the notebook, and it actually has more than one table. We are only going to look at one table, and that's the teams table. And in particular, we're only going to look at two columns in that table. G stands for games, SO stands for strikeouts. Okay, and the year ID and franchise ID and name are essentially there to give you an indication of which team does the score correspond to. So let's start by reading the data. Okay, so you have the year, franchise ID, name, games, and strikeouts. Okay, so the first step is to really start thinking about each of the data for each of the lines, right? I'm a big fan of pre-computing the data as much as some frameworks allow you to compute on the fly, like ggplot does, for example. Very useful. I find it, easier to create the data, munch the data in advance, and then just use the visualization layer just to plot it, right? So let us start by looking at the various layers we need, right? So first we need let's look at the blue line, right? So the blue line here is basically the league average, and the orange line is for a particular team. Okay, so and we're only looking at data after 1990. So I'm just going to first create a data set which is team level SOG, that is strikeouts per game. Okay, so I'm going to call it team SOG. Okay, so basically we're going to start with the team's data. Okay, and I always like to set up my code such that I can visualize the output as I write the code. Okay, so in this case, the team's SOG, the first thing we want to do is we want to only take data that is greater than 1900, right? Or let's say equal to, greater than or equal to. And so you can do that by adding a query statement. So the query method basically filters this data frame, pandas data frame, and only looks at everything above 1900. Okay, it all looks good. And just to make it things easier, I'm just going to do a head here so that it doesn't print everything. Okay, so far good. Then the other thing is I need to add a strikeouts per game entry, right? So the way I can add a strikeouts per game entry is using the assign statement. The assign statement adds an extra column. And so this one here is going to be, I'm just going to call it SOG, SOG, that's strikeouts per game, equals, and you're going to use a lambda here. It's going to be d.so by d.g. Okay, I'll just explain what this is doing. Let's run it. So assign is a useful way to compute a new column. And in this case, we're computing a new column for strikeouts per game. And we're instructing pandas to construct it by taking the strikeouts column and dividing it by the games column, number of games column. Okay, so this is the team SOG. Now we need a couple more to go. So this data is going to be enough to plot the scatter plot. Okay, maybe that's the way we'll do it. So let's actually go back and forth between data and visualization. Yeah, that will be helpful so that you can see why we are computing something rather than just me computing everything in one shot. Okay, So what I'm going to do is I'm actually going to open another code cell. And the way you open a code cell is by clicking on the plus here. So you have another code chunk here. And so this is going to be, I'm just going to call this compute, pre-compute data. And then here I'm going to say plot data. Okay. So let me actually add a couple of comments here to kind of talk about the plan here, right? So we're going to do plot setup first, and I'll come back to what that means. Once we set up the plot, we are going to add a scatter plot layer, and for all SOGs, right? So this is the data that we kind of computed. And let me then add a couple more here. Then we're going to say add a line plot layer for a specific team. And in this case, I'm actually going to do the Boston Red Sox, although I am from, although I am in San Francisco, I'm going to use the Boston Red Sox. And then what we're going to do is we're going to add a line plot layer for the league, right? For the entire league. And that's basically the blue line that you see here. And let me just make that point here. There's the blue line, and this is the orange line. Okay. And finally, what we need to do is we need to add text annotation layer, and then we need to add title, subtitle, etc. And then we can expand on this. So this is very useful, again, like adding these comments, because then, I mean, in your mind, it's very clear like what the plan is, right? So let's start with the plot setup. So the first thing I want to do is I want to basically make the plot a little bigger. So I'm going to basically say figure.fig size. This basically allows you to set the width and the height of the plot. Okay, and I'm going to say, okay, let's make it 20 by, let's say, 8, and we can play around with this, right? So that's the first thing. Second thing I'm going to do actually is I'm going to use, so I really like the Matplotlib has a lot of different styles. So one of the styles I really like is the 538 style. So it creates some really cool plots. So I'm going to use the 538 style. Okay. So far we are good. So let's get started now. Let's kind of add the first layer, right? That's the scatter layer. So the way you add a scatter layer is using plt.scatter. Okay. And I'm going to add one argument per line so that it's very clear. So the first argument is going to be the x axis. And in this case, it's going to be the team SOG. And I'm going to use the, sorry, the x-axis is the year, sorry, my bad. So the team SOG year ID. Okay, and then let me then add the second one, which is team SOG. And this is going to be your SOG, strikeouts per game. Okay. I want the color to be light gray or gray. Let's just keep it gray, right? And I want the points to kind of recede back into the background. The points should not be the ones that are prominent. So the way to do it is using an alpha argument, which essentially is a transparency, controls the transparency. Okay. So let's see what this yields. Let's run this code cell at this point. Let's see, I mean, if it uses anything reasonable. It does seem to be giving us like some bits. It's different from the original plot. And the reason it's a little different from the original plot is because we chose an alpha here. If we had just gone with a lighter color, we would get exactly what's there. And I'll explain what the difference is. So if I kind of comment out the alpha and just go with a light gray, right, then you just get exactly what you saw in the previous plot. Okay. I personally like the alpha because the alpha sort of allows you to see overlapping data points. Okay. So I'm going to kind of not do a faithful recreation here, but use a little bit of discretion and say that, okay, I like the alpha. I'm going to keep the colors gray, but this kind of also shows you like, okay, there are lots of teams that are kind of clustered around here. Okay. but maybe reduce the alpha a little bit so that like it's not too dark. We don't want this to be prominent in the plot. Okay, so there we go. Much better. Okay, so we have a pretty good starting point. Okay, so now let's start adding the various layers. The first layer we're going to add is actually easier layer we can add is the team specific team, right? Because it's just a simple filter. So I'm going to go back up here. My apologies for going back and forth, but I think it's better from a helping you understand the construction perspective. Okay, so we will go across 2 code chunks. So what I'm going to do here is I'm going to basically say Red Sox, right? Like say Red Sox SOG. Okay, and then the way I'm going to get that is I'm going to basically do here teams. Actually, I'm going to start with the team SOG because it's already been filtered. So let's start with that. And then the query is going to be name equals Boston Red Sox. Now feel free to do it for your own team. The only caveat I would add is that this data really doesn't correct for team name changes. So one reason I didn't pick San Francisco Giants is because I think the team was called something else previously. So you don't have data for the entire sequence. You need to do some data munching to kind of clean it up. And I didn't want to do that. So if you pick your own team, yeah, just be wary that the data might be a little messy. Okay. And let's quickly just also look at the data to make sure that it's in order. There we go. Okay, it does look like it did pick up the Boston Red Sox. Okay, so let's go to the actual data now. So now we need to add a line plot layer. Okay, so the way to add a line plot layer is basically we use a PLT plot. So by default, this does give you a line plot. Matplotlib is extremely consistent. So basically, the arguments are going to be very similar. So I'm going to say, okay, in this case, I don't want to use team SOG. I'm going to use the Red Sox SOG here. And if you're calling, if you're doing it for a different team, feel free to change that based on what you're doing. So it's Red Sox SOG year ID, and then we're going to do Red Sox SOG. SOG again here, and color. I'm just going to call it orange. Again, like faithful recreation, you will have to do a little more where you go to the actual plot, extract the color on that page. So I mean, if you want to be a purist, you can do that, but we're just going to just wing it here and just take color orange. Okay. So that's pretty much what that's what we have here. And so let me just sort of plot it. So yeah, that looks pretty good. So we do have the team layer, and it looks like the data is missing for some years, and that could be either a data issue in the database or maybe the number wasn't tracked. Something to kind of look at, right? But yeah, overall it looks pretty clean. And let me go back to the actual plot to see whether there were any dots. So there were dots in the original plot. So there's a line and dots. So let's try to get the dots. The easiest way to get the dots is actually to add a marker argument. And what the marker argument does is basically allows you to add different shapes, right? And in this case, we're just adding a point. So let me click on it again, and you can see that there are dots, right? They're a little smaller, but we can eventually fix the size of the dots. I don't remember top of my head the argument for the size, and so like I don't want to waste time, but time permitting, we'll go back and fix the size. Okay. And this is another personal note on visualizations. As you learn it, like focus on the basic concepts and focus on the high level arguments, right? Matplotlib has so many things to tweak that you will never fit everything in your head, and you don't need to fit it in your head as either, right? So basically, you can, knowing how to look it up and knowing what it is kind of more important. And this is a personal tip from having done visualizations for a long time. So good. So this is good. So let's kind of keep moving, right? Move a little faster now so that we can finish this visualization within the 40 minutes that we have for it. So the next thing we want to do is we want to do the blue line, right? And the blue line is basically the league level strikeouts per game. So in other words, it's saying that if I look at all the games played by all the teams in the league, and if I look at all the strikeouts summed up together, right, what's that metric? So the way we're going to do it is we're going to call it league SOG. And as usual, we kind of start with the same team SOG data frame. And what we're going to do here is we are going to group by the year ID, right? So we want one per each entry, okay? And I'm going to add this as index equals false. I'll explain to you why I add this as index equals false, okay? And then I'm going to basically use agg. And in this case, let me see if I get my syntax right. So it's going to be SOG, and then we do a lambda, and then d dot g dot sum by d dot so dot sum. I might be wrong here, but let me just check it before I start explaining what I'm doing here. Okay, so yeah, okay, so this is not going to work, like, because aggregations don't take a sum. So I'm going to use a slightly different approach here, right? I'm first going to do a sum here. So we're going to sum both the columns, okay? The SOG column should not be summed because it's a ratio of two metrics. So what I'm going to do here is I'm going to then assign SOG equals lambda d dot g divided by d dot so. Let me see if this gets me what I need. Lambda, what did I do wrong here? Okay, there's a typo here. Instead of lambda, I typed lambdba. I should have spotted that, and much better, much better. So these SOGs are essentially at the league level, right? So let's see if the visualization is consistent with what we saw earlier. So I'm going to use the league SOG data and add a scatter. I'm going to take a slight shortcut here to save time. It'll also save time for you. So rather than rewriting the code for that plot layer, I'm just going to copy this plot layer, okay? And the reason is that both these plot layers are identical, except that the only difference is that one is based on the league SOG, whereas the other is based on the specific team SOG. And of course, the color is going to be different, right? So let's plot this, see if we are getting closer. Okay, there seems to be a problem where, yeah, so these numbers are not really in line. So the numbers are computed are not in line. And I think I know the reason why. I think there is an issue with how we compute it. I'm just going to quickly check what I did to get this. And okay, so what we actually need to do is basically just take a simple mean of the SOGs, because that is what was being plotted earlier. This is a weighted mean, and there are issues with the weighted mean. So my apologies for leading you down that path. So we're going to sort of ignore what we did before and just say that I'm going to just take a average of the strikeouts per game, right? So I have all these strikeouts per game. I'm just going to take the average for each year, a simple average, which kind of, now that I think about it, makes more sense. Okay, so let's kind of do the plot. I'll come back to the data to explain what was happening, and let's do this here. So there you go, right? So this looks much better, much closer to what we were seeing earlier. Let's just compare. Yeah, so you see this goes up, it's a dip, again goes up, comes back. So we're seeing all those artifacts here, and so it looks consistent here. So going back here, just to kind of quick reminder on pandas here. So what we're doing here is we're using the aggregation function, and we're just aggregating the pre-computed strikeouts per game, right? So we're not adding up games and adding up strikeouts and then taking the average there, which led to a different kind of a plot. So I'm actually glad I made the mistake, because it serves as a reminder, like, yeah, when you do this, yeah, you need to remember how to sort of like how to think about what's happening, and then yeah, figure out the fix. And we figured out the fix here. So we're all good so far. We have most elements of the plot here. So then I'm going to add the annotations. Okay. So the annotation layer again is basically plt.text. So this is the annotation layer. Okay. And plt.text basically takes, like, again, you can take an x and y argument. I'm just going to quickly remind myself of the syntax of plt.text so that I don't fumble here. So x, y, basically where to place the text, and s is a string. Okay, so that's the argument, and then you can specify a lot of things about the font. This is a useful thing in JupyterLab. For those of you who've been doing Python in JupyterLab for a long time, you know this. But for those of you new, just type a question mark. You get the help that you need. Okay. So plt.text, and so the first one that I want to place, if you go back to the plot, I'm only going to place one because it becomes repetitive. So you can do the remaining pieces on your own. So US enters World War I, roughly. Yeah, I think it's like 19. I don't know I don't remember the years top of my head, but let's just say 1915 and or 1914, and let's just use that. Okay. If you want to be thorough, Wikipedia it in terms of when US entered the World War and just have the correct dates. So we're going to say XY. So we're going to basically put X is 1914, and yeah, and the Y I'm going to basically look at the Y here again in the plot. So the Y, we want the annotation to be somewhere here, which is around 1, right? So they basically put 1, and then yeah, and then your string is US enters World War I. Okay, so let's see what that does. Yeah, so you see it's here, but it doesn't quite look like what we got earlier. It kind of goes all the way down, and the reason for this is that this plot actually starts from 2, whereas the original plot starts from a 0. So we're going to fix that by actually setting the axes limits, right? Basically change axis limits. And if memory is not wrong, PLT, I think it's xlim. Let me just confirm. Okay, it is xlim, and then yeah, you do the left and right. So in this case, actually it should be the ylim. Sorry. So the ylim is going to be. I'm going to put it a little below 0, and I'll explain to you later why I did that. And the top one, I'm going to leave it at 10. So with this fix, I think it should be reasonable. Yeah, you see the US enters World War I. It's kind of nice. You can add an arrow. So if you look at the documentation for this, you can also add an arrow. I'm not going to do that in the interest of time. The solution notebook, final solution notebook, will have the arrows. Okay, so this is how you add the annotation. So finally, we need to add the titles so that we can kind of wrap this up. And one other thing which I kind of personally like is basically like a horizontal line at the 0 axis. And the way you do it is using an AX H line. So this is like a Matplotlib is very, I would say, concise in terms of like the methods, but once you know them, they all make sense. So add a horizontal line across the axis. So we just want to add a horizontal line at 0 that is basically black, right? So we'll do that here and just say plt.axh line and then xmin equals 0. Yeah, and it's blue. Like I'll change the color here. So color equals black. There you go. There you have black. Much better. Okay. So final thing I want to add the titles. Now for the titles, I'm actually not going to use the title, matplotlib's title command. I'm going to use text again, because text allows you to place it exactly where you want, right? I'm also going to create some space on the top so that we can put the text. So I'm going to actually change the while limits to something like 13, so we get more space on the top, right? And basically, then I'm going to add title subtitle. I'm going to say plt.text, right? And I'm going to do it at 1885 and let's say 13, and then s equals strikeouts. Strikeouts are on the price. Okay, and let's do this here. Yeah, I mean it's really small, so we need to kind of then look at font size. Let me put it at 24. Font weight equals bold. So a whole bunch of options that you can tweak. Okay, and maybe you want to have it a little higher, so I'm going to put 15 maybe, so that it's more space, right? And then you can do the same thing for the subtitle, where you can say plt.text 1885, have it a little lower, maybe 14, and then s equals I don't know what the prompt was. There are more strikeouts in 2012. Yeah, we can just, I'm just going to leave it as there were more strikeouts. There were more strikeouts, and then let's leave it at that. And then this font size I want to be a little smaller, equals 16. Font weight, I don't want a font weight to be bold or anything. So there you go. So I'm going to pause at this this point. We're kind of nearing the 40-minute mark, and I have spoken quite a bit, and we have gotten to we've done the plot, gotten pretty far along. So at this point, I will take questions. So if you have questions, please put them in the chat. My colleague Yash will basically will read them out, and I will try and do my best to answer those questions. Right, I may not have answers for everything, but I will do my best.
Okay, thank you, Ramnath. So we have a question from Soumya. Can you explain assign again, please?
Excellent. So yeah, let me go back to assign. So assign. So if you have done pandas, like the usually the classic way of creating a new column in pandas that you might be used to is basically where you say teams SOG equals teams G divided by teams teams SO divided by teams G, right? So this works, and in fact, like a lot of pandas code I see like is written this way, which is perfect. But I prefer the method chaining approach because it's easier to add new things and the flow becomes a lot clearer. So the best way to think about assign is assign just does this, but with a simpler syntax, right? But if you're more comfortable with this approach, by all means do that. Little bit of background, like I come more from the R background. Like I've done a lot of R, and like in R, if you follow tidyverse and dplyr, the flow is more like chaining of functions. So my Python code also tends to be more along those lines. So TLDR assign just does shortcut to do this.
Okay, thank you, Ramnath.
Next question, Yash, yeah.
Yes, so the next question is from Quinton. They ask, what does team_SOG stand for? And specifically SOG, strikeout per game. And there's a similar question from Leah, who would like to know what the variables are, SOG, and yeah, everything that we created, and the G as well.
Yeah, I'll try to do my best here because I'm not a baseball person. So G should be pretty clear. G is the number of games that a team played, right? So that's G. The name is the name of the team. The franchise ID is just the three-letter abbreviation that's used for the team. Year ID is clear. It's just the year in which this data was recorded. SO stands for strikeouts here. And I believe strikeouts is a metric that's tracked in baseball, which corresponds to the number of times like a batsman gets stricken out, and that's the extent of my knowledge on baseball. I mean, you can Wikipedia this, figure out exactly what a strikeout means. But best way to think about it is it's a statistic that tracks, the number of times a batsman has been stricken out in a game. I'm sure the more baseball savvy folks here would have a longer explanation and a better explanation. And so that's the first part. The second part, team SOG. So basically, I always like to so whenever I add a new column to a data set, I try not to add it to the original data set. I try to add it to a new data frame, and the whole reason is that it just makes it easy to keep track of things. So because I'm adding SOG to the teams, I just call it team_SOG. Strictly speaking, I should have called it teams_SOG, but I did not. So it's just, I call it SOG because to say that this is adding the SOG column to the teams data set. Okay, but nothing sacrosanct about the name.
Okay, thank you, Ramnath. And the next question is from Anupama. Why don't we have to use plt.show?
Great question. So the reason we don't have to use plt.show is because we are in a Jupyter notebook, in a Jupyter Lab notebook. So Jupyter Lab notebook automatically does plt show for us. Now you could kind of add a plt.show at the end. It won't be wrong, and maybe we should, because then this code, even if you convert it to a Python file, will still run correctly. But long story short, we don't need it because Jupyter Lab takes care of it for you. The one advantage of using plt show, though, if you have noticed carefully, is if I don't do plt.show, you see this really ugly text statement, which is basically the output of the last statement. You can silence it by adding a semicolon, but maybe the better way to silence it is by adding a plt.show explicitly. So that's the reason why I didn't really bother adding a plt.show.
Next question is from Michelle. What did New York Times use to make the graph interactive? And are we going to see it how to do the drop-down menu like in the article?
Good question. So I think New York Times, again, I don't know the exact stack they use for this, but it seems like, I don't know if D3 was around at that time. Maybe it was, but a lot of the interactive visualizations New York Times typically uses D3 and JavaScript. You can actually create an interactive plot. You can make this interactive with Python using Plotly. I chose not to do it on purpose because I wanted this to be more of how to reconstruct the plot. So if you use Plotly, you can reconstruct this, to a fairly good level of interactivity with, like, I would say, mouse overs and like tooltips and other things. If this is a topic of interest, we could do an entire code along focused purely on that, right? In terms of drop downs, so you can do it in Jupyter Lab, like as a using some interaction widgets, but you can't publish them because they require the Jupyter kernel. So like you can use it to explore data in the Jupyter Lab, but not publish it. So for that, you will have to write an entire app using Plotly and Plotly Dash, which kind of goes beyond the scope of today's code along. But there is enough interest. Yeah, we can definitely do a thing where we just do the same thing, but just turn this into an app directly from Python using Plotly. I know not a complete answer, but like, yeah, no, we're not going to see that in today's code along.
Okay, thank you, Ramnath. Next question is from Jim. Why did you duplicate the plot line of code? Is it hard to define a Python function here?
Great question. Great question. So usually any plot development is a highly iterative process, right? And in general, I like to keep things dry. But usually there's a trade-off between like when do you turn something into a function versus when like a simple copy paste actually makes more sense. And so typically, like, I draw the line at like 3. So if I'm doing the same thing like more than like 3 or more times, like I turn it into a function. If it is 1 or 2 times, like the extra cost for defining it into a function is not justified. Like, the copy paste is much quicker, right? So that's why I did a copy paste. But if, let's say, I wanted to overlay a line for every single team, then I would have definitely turned this into a function. But since only two, I said, okay, you know what, let me just copy paste. It's much faster and much clearer in terms of what's happening. But good to know you're thinking along those lines. Like that's exactly what's going to get you to become more solid in the way you write code for the visualization. We'll take a couple more questions, Yash, and then I think we need to move on to the next visualization.
Okay, sounds good. So next question is from Dor. Can you please clarify the syntax of the .agg method? They're familiar with something else.
Yeah. So the .agg method is actually a newer method in Python. So you might be familiar with the aggregate method, which is also kind of where you use dictionaries and stuff. The agg method used the new Python 3 point. I forgot which version of Python introduced it, called tuples, named tuples. And so the reason why I used it here is it allows you to name the aggregate variable cleanly. And of course, in this case, I'm still calling it SOG, but let's say I wanted to call it average SOG, right, or SOG average, right? Then the agg method supports it. And the way the syntax basically takes the first argument is a column in the data, and the second argument is a function, right? And in this case, it's a main functions already defined in pandas. So I mean, yeah, I chose it because I like writing it this way, but you could also use aggregate and like pandas has I think at least 2 or 3 different ways to compute aggregates.
Okay, we'll do one more question.
And then we'll come back to more questions if you have time at the end.
Okay, so the last question is from Ben. How are the horizontal gray lines implemented for text annotations?
Okay, so the horizontal gray lines, so the way you do it, you define a arrow dictionary, and let me actually just copy paste it so that it's much faster for me. So basically, yeah, you add something called arrow props. So let me do it here, and yeah, it's also probably good to just name the arguments. It's better coding practice, right? Overall. So you use arrow props, okay, and you can then specify the color of the arrow and the style of the arrow. And Matplotlib has like a gazillion different ways to specify the arrow. So if I run this, let's see, there's a problem. Text property has no arrow props. Let me just go back here. Okay, so the problem was that I used text. I should have used annotate for the arrows. So my apologies for that. I'm just going to copy paste this whole thing and then I can explain it to you as we go along, right? So let's do the plot here. And yeah, so we use an annotate layer. It's exactly similar to the text layer, except that like you can see, because you have an arrow as well, right? You need to also specify where you want the text and where you want the text, the arrow to start. And the arrow props is a dictionary where you specify what color you want, what is the arrow style, right? So with this, you see that yeah, it adds an arrow, and you can tweak the parameters here to kind of like get it to be straight. There might be other tricks out here. So yeah, so to get the arrows, you need to use annotate and not text, and but the syntax is pretty similar. So I think that'll be the last question for this section because we need to move on to the next one. But thanks for all the questions. We'll go back to the questions like at the end if there is time. But it's time to kind of do the next data visualization. Okay. So yeah. So I'm going to go to the next one. So the next one is a more recent one, and as much as I try to avoid doing visualizations with COVID, given that that's the news that is front and center like every single day, and people are probably sick and tired of hearing about it. This is a really beautiful visualization, and I thought it's kind of an unconventional one that yeah might be worth taking you through so that you get a sense of like how how to kind of do something like this, right? So let's focus on the visualization itself first. Now, we're not going to do a faithful recreation. Like, I'm going to do most of it, but not the entire bit. I'm going to leave that as an exercise that you can do for later. But what exactly does this visualization show? So let's actually look at, so this is a good example of what's called a small multiples plot. So small multiples plot is a really powerful visualization concept where the idea is if you have a lot of data to present, right, you figure out how you want to present one piece of the data and then just present everything similar to that piece of data, right? And like, for example, here, let's take one state here, right? So this is Washington, and this is basically looking at how many cases, right? COVID cases, and this is a really old one. This is March 21st, 2020. So the numbers are dated in this plot, okay? Just so that, just so that you're clear. And then you see that it just replicates it for each state, right? Where like the same plot is shown in various places. Some really clever use of overlays. So for example, the yellow overlay here looks at when the first case was detected in a particular state, right? So it adds a little more context to kind of look at how fast the cases have been rising, which I think is really clever. Second, you also see that the x-axis has been like just only one data point is showed in the x-axis, which is like this data start of the cases. So it gives you a lot of context, right? Finally, like a really good use of like an anchor right at the top, so you can see, I mean, how many you can use this to understand what does each number mean, rather than pushing it to the text. Like they put it here. This is really good visualization practice, right? So that the user has all the context. And finally, I mean, something that like, yeah, finally, I haven't figured out a way to replicate it. Maybe one of you will, but like New York cases just kind of went through the roof in March, and they figured out a way to kind of take this part out of the plot. I haven't spent too much time trying to do this, so I don't know how to do this, but a good challenge in case you're interested in taking this to the next level. And finally, like a really good use of what I would call like placing each state on a grid, right? So this also gives you extra information on geographical context. So for example, like from this, you can see, like at a quick glance, you can see that like the states where you have a longer, where cases started early and there's a longer duration, a bigger rectangle, yellow rectangle, it's typically like on the west coast and so on the coast, right? Where, I mean, there's also more population. Illinois is also like, yeah, same thing. So it allows you to kind of see a lot of geographical patterns, if you may, right? So overall, I would say like a very carefully thought out data visualization that packs a lot of things into like one piece. And so as a result, it's an excellent visualization to learn from, okay? So after all that talk, let's kind of go to the data sets itself. So the first data set, again, so New York Times has been kind enough to release this data set, and in fact, they keep it updated. So it's a very simple data set that looks at date, the state. It has a FIPS code, which we're not going to be using here. Then the number of cases on that date, new cases, and then the number of deaths. Okay, so we're going to read it straightly from GitHub. So this is the latest data that they have tracked. I think they're updating it. Like I could be wrong. We can quickly check that by saying sort values by equals date ascending equals true, and then do a head. Okay, so looks like, yeah, they didn't update. Oh well, ascending equals false. That's what I want to do here. So yeah, so it looks like they have kept it updated. So this is 29th of August 2021. So it's basically the latest data. Okay, so that's the first one. The second data that I provided for convenience is actually you need these items on a grid. So you need to know like what's the position of each state on the grid, right? So you can manually code it, but the hard work has already been done. Like, so there is an R package actually that has this data. So so full credit to the author of the R package, and basically I took it from there and just dumped it into a CSV file and just put it in there. So this is basically saying it gives you an X and Y coordinate for that particular state. Okay. So now that we're kind of fully set up, like let's try to recreate this plot. So we're going to use a slightly different approach here. And in the interest of time, I'm going to copy paste some code so that I can then write the remaining code, and we'll still be able to get to the end of the presentation. Okay. So I'm going to just copy these bits of the code, and then I'll explain each. Actually, maybe I'll just copy the full piece so that we have it ready to sort of build from, right? Okay. So the first thing I'm going to do, again, I'm going to organize the code the same way, right? We're going to do a plot setup, okay? And then what we're going to do is we're going to plot the bars, right? Bars or line plot lines for each state. Okay. And finally, we can then do we'll figure out what are the remaining things to do, right? So the first thing I want to do is I want to really set the RC params here again, and I like a square layout here. So we're going to actually switch the figure.fig size and basically set it to let's say 20, right? Squarish. We can tweak that later. And I'm going to change out of the 538 theme. So I'm going to use Seaborn. I'm going to use Seaborn here. Okay, Seaborn looks nicer for this kind of a plot. Okay. And so then what I'm going to do is I'm going to introduce a very cool feature in Matplotlib, right? And that's basically what's called a grid spec. Okay. So let us complete the setup here by defining a fig and then saying this is just plt.figure. Okay. So this is basically the way you initialize your figure object. And there are many different ways of creating subplots in Matplotlib. You might be familiar with the add subplots method. But the way we are going to do it is we're going to actually use a grid because it just makes it so much easier to add the subplots. Okay. So what I'm going to do here is I'm actually going to define a grid object. So let's actually write the code here. Let's say define a grid object. Okay, and I want it to be a square, so that's why I'm actually making it 2020. So we're going to add a grid spec here. Okay, and I'm going to make it 13 rows and 13 columns. Now we don't need 13 rows and 13 columns because obviously the grid is kind of flatter, but this will kind of make sure that all the individual panels are square, right? It kind of looks nicer. Otherwise, it kind of looks weird. It looks a little squished. May not be visually appealing. Okay. So the next thing we want to do is we want to loop through each of the states, the coordinates for each of the states, right? And then we want to add a subplot for each of the states. So the easiest way to do that is using a for loop. Okay. And so we're going to say for state coords in, okay. Actually for state, let's just keep it state, and then let's do state coords. And I'm going to convert it to a dictionary, and we're going to orient it as records. Okay. There might be more efficient ways to actually loop through the rows of a pandas data frame, but I'm going to just use this method. It works. So just to kind of show you what this looks like, it's basically turning the data frame to a list of dictionaries, because then basically you can loop through it. You can pick the X and Y. Okay. Let's actually just, okay. Oops, did I delete the whole thing? My bad. Good thing we have this. So I'm just going to copy this bit again here, so we can still, okay, good. So the next thing we're going to do here is we're going to add a subplot, okay? And the way you add a subplot is basically using the fig add subplots function. Okay, and what the subplots function does is basically it adds a subplot at a particular location, right? And in this case, what we're going to do is we're going to do GS state Y, and then we're going to do GS state X. Okay, and let's actually we need. I made a mistake here, and let me just clarify the issue here. It takes the grid object basically takes like the coordinates together. Okay, and maybe let me see if I can create a simpler example of this so that you can follow it easier. Okay, I made a typo here. It's a subplot here. That's this one. We're still not doing any plots here, but I mean you can see that we at least have a grid, right? And so let me just spend some time on this code so that it's very clear, because the remaining part of the code is kind of just creating that single plot, right? So what we're doing here is first we're saying that I want a grid of 13 by 13, right? And then we are looping through all the states, and we're saying that, okay, I want to create a subplot at this location. So in this case, like at state Y and state X, I think they've been reversed at some level. That's why I kind of do state Y, state X, right? And basically then you have all this. Okay. So I'm actually going to, in interest of time, I want to make sure I get to the full finish of this. So I'm going to use the code that is already there. So that way, like we can get to the finish and you can see everything that's been done and I can take questions. Okay. So I'm going to move back to this copied code snippet. Okay. And then explain what I'm going to comment out everything so that you can see each step in detail. Okay. So this is so far is good. And then let me comment this out, and then we'll go through that. Okay. So this is basically the plot, right? So you have all the things. First thing we want to do is we really want to get rid of the grid lines, right? We don't want the grid lines, and we also don't want the numbers here, right? The numbers are not useful in this plot. So the way to do that is Pandas has a method called AX on the axis. You can say AX.axis, x-axis, and set the visibility to false, right? So, and what we're doing here is we're setting the visibility of both the x-axis and y-axis to false. And what this will do is this will remove the grid and also remove the labels that you see here. Okay. So let's just do that here. And there you go, right? I mean, this is a totally useless plot, but definitely cleaner than what you saw before, right? So now it's time to start adding information to this plot. So how do you add information to this plot? So the first thing we want to do is we want to get the name of each state, right? And the reason I want to get the name of each state is because if you think about it, the state name is displayed on the panel, okay? So the way you get the state name is, again, you say state name equals state and the name of the state, the state column, and this will get you the name of the state, okay? And what we want to do is we want to get the data for that particular state, right? COVID cases is for all states. So the way we get the data for each state specifically is by taking the COVID cases data and then filtering it, querying it for the particular state in question. And again, Pandas tip, if you want to really use a variable in a query statement in Pandas, I mean, you use the at syntax. So what this is saying is that when you use at state name, it means that please replace, I mean, whatever is an at, whatever is reference here by the variable that, I mean, that is there. Okay, so that will get the data, and then the plot is pretty standard. What you want to plot is you want to plot date and cases, right? X-axis is date, y-axis is cases. Okay, so let's run this, and I will do a recap of like the steps so far. Yeah, so basically you can see that now you have a plot for each state, right? Actually, wait, there might be an issue here. No, there's no issue here. I'll explain why they all look very similar, right? So they all look very similar because like each plot has its own axis, right? So effectively, the min and the max is not the same across all the states. So that's why it looks like all these panels are showing the same piece of information when they're actually not, right? So how do we correct for that? So the way to correct for that is to basically set the y-axis limits for each panel to be the max y to be the max number of COVID cases, right? The way you do that is using the ax.setYlim. So this method allows you to set the y-axis limits, and I set -1 so that we get a little room at the bottom. And then for the max, I'm taking the COVID cases max. I'm not taking the max of that state, because if we do that, then it just defeats the purpose. I'm taking the COVID cases for the overall for all states put together, right? So now if I plot this, the plot becomes a little more meaningful, and you will see now that you will see the states where, like, for example, California actually had again, this data is updated to the latest. California had a second phase where, like, there was a lot more people tested positive, and then you can see how the curves basically look like, right? So much you can compare the curves now, right? So final couple of things I will do, and as I said, like, we're not going to do everything in that plot. I'm going to leave it as an exercise that, like, you can work on it. It's going to be time consuming, but it's well worth, like, especially if you plan to create visualizations that you want to kind of dot the i's and cross the t's and be, like, fully publication quality. The extra effort is totally worth it, right? So the next things I'm going to do two things. One is I want to add a text. I want to add the state names, right? And the way to add state names, one way to add state names, like, a common location is probably like the top left corner, right? And the top left corner is basically 0 x-axis, and the y-axis is the max number of COVID cases, right? So we can essentially add the title, not the title, but the panel title, by using text and saying, okay, I want you to add text at 0. And the y, I'm adding a little bit of a correction factor here because the text occupies space. So you can see what happens if I don't add a correction factor. And let's see what happens here. So you can see that, I mean, this kind of looks nice as well. But if you look at the original visualization, like, I mean, the top left is also a space that doesn't have, like, the line there. So it's actually a nice spot to use because there is no data overlap, right? So if you want to move this inside, one way to do it is just add a correction factor. I played around with a couple of correction factors. 8 seems to be a reasonable one, where, like, it's just inside, but still leaves enough space to be clear. Okay, so, like, and then the rest of the arguments are all, like, logical. So I added a font weight, I made it bold. Maybe bold, yeah, I don't know if it's it throws too much attention. You can also think about a different color for each state, right? You could think about states where, like, the cases are on the rise, like the 7-day increase in cases above X, like, you can color it red, other states green. So possibilities are endless in terms of improving the plot. The final one I will do, which I think it requires more work, but just to kind of show you, like, how to add a patch, and this is where I think more work is required to get it to the New York Times plot, is you can use add patch. This is a really nice method, and Matplotlib allows you to add a rectangle. And what this is saying is that add a patch, a rectangle, starting at 4040. 4040 here is the number of days from, like, the starting point, and then yeah, I mean, then the width is 360. So you're kind of plotting it over 360 days is the extent of the rectangle, and then the y is COVID cases max. So let me actually run the code so you can see what. Okay, the rectangle is not defined. That's because I forgot an import statement here. I'm going to put it here from matplotlib.patches import rectangle. Okay, so this should correct it. And then you can see that it will overlay a rectangle on top, but the rectangle is all positioned at the same spot, right? And so this is 4040. 360 is basically, like, the maximum of the X axis, and the COVID cases max is the Y extent, right? The reason I added it in here is to give you, like, a starting point. and I leave this as an exercise. So if you really want to get to the New York Times plot here, you need to do two things. One, you need to calculate the starting date of when the first case was recorded in each state, okay, and then you need to anchor the 0 to that, right? And once you anchor the 0 to that, so what will essentially happen is if you need to pre-compute, and then here in this rectangle, this 4040 will be not 4040, it will be the number of days since the anchor when the first case was detected in that state, right? That will be your 4040. 360 will then be like, I mean, you don't need, yeah, it'll be the current date minus the first date, and then COVID cases max will still stay the same. So it can be done. It just requires a little bit of data munching, and yeah, I don't have time to kind of do it at this point. And finally, let's kind of add the last two things here so that we're kind of almost at time. So like I want to make sure at least some time for questions. We do a soup title. So soup title is basically when you have a lot of subplots, soup title is kind of a super title. If you just do title, you will get the same title for every single panel, which is going to be a disaster, right? And finally, like, yeah, let me not run this for now. Like you can see what the impact is. Yeah, and I'll add my plt.show so that I get rid of that ugly statement at the top. Yeah, so you see that there is a lot of wasted space, right, from the top. So one way to kind of do that is like do a fig.title layout. So this basically instructs matplotlib to kind of like, I mean, tighten the layout a bit. There is still some space left at the top. I mean, you would have to spend a little more effort in kind of, if you really want to reduce it further. Actually, this is not that bad. It's some space, but not a lot, right? So we didn't quite get to the actual plot, but we kind of went quite some distance in terms of recreating it. So I leave it as an exercise. If you really want to get to the New York Times plot, you need to pre-compute the first day on which the cases occurred, and then use that. Okay, I'll try to add it to the solution so that I mean, if you want to look at how it is done, you can figure it out from that. But it's worth exploring on your own. So at this point, we're kind of close to time, so I'll take a couple of questions, and yeah, yes, yeah, let's do some questions, and then let's wrap up so that yeah, we can give people back their time.
Okay, thank you, Ramnath. So the first question is from Chin. Is there any practical difference between using plt.text and ax.annotate for annotating a plot?
Good question. So matplotlib basically, like, so okay, the difference between a fig and ax is that fig is the overall figure object, right? So that's why, for example, here, if you see, this is a good example where like when you do plt.subtitle, you're adding it to the entire figure, okay? Whereas ax refers to like one plot or one subplot, right? So typically, if you only have one plot, well, the fig and ax don't really make too much of a difference. So you can create it using both syntaxes. But when you're creating a lot of subplots, and the fig and ax start to make a big difference. Okay, so that's basically a quick answer. Like, and then the method names are slightly different when you do it on ax versus plt. So one good example is like if you do whilelim, you do set underscore whilelim. Whereas if you do it on the PLT object, then, I mean, the fig object, then you do PLT.whilelim, right? So, I mean, they're consistent, but they're still different.
Okay, thank you, Ramnath. And the next question is from Maha. Right now, visualization is turning into its own separate role, plus moving into more BI tools. So what's the role of visualization in data science now?
Great, again, great question. So there are two. Okay, so there are two things about visualization, right? So one is visualizations are constructed for exploratory analysis. They're also constructed for storytelling, right? The BI layers typically, in my mind, given that BI layers, like they kind of usually offer canned set of visualizations, right? BI layer is really great for like some exploration and definitely some communication as well. But the minute you want to kind of do some like harder statistics, like and things like that, I mean, you will have to kind of resort to sort of writing code using R or Python to do it. So I would say that like visualization definitely still has a big role to play in the data science workflow, because as a data scientist, it's your best bet to understand the data, right? So yeah, I think definitely there is. I mean, there is a place for both, in my opinion. So it's not like the visualization is completely being relegated to the BI layer, right? Plus, I mean, as I've shown, like the doing it this way, like you have complete flexibility in terms of how you want to really visualize your data. BI tools, I mean, for ease of use, they constrain you to some extent in terms of what you can create, right? So TLDR, like, yes, there is a role for both. And I think as a data scientist, like definitely investing your skills on visualization will go a long way, because it's your communication to the outside world, right? Everybody can read a visualization. Not everybody can understand the stats.
Thank you, Ramnath. And the next question is from Kapil. Is it possible to add a background image to the plot? Let's say a map of the US behind the plot.
Great question. With Matplotlib over time that I've learned that, like, yes, you can do anything. And I haven't done it. So I will have to sort of look it up. But again, I think it's a good challenge. Look up how to overlay images in Matplotlib. There is so much documentation available out there. So I'm reasonably certain it's only adding a couple of lines of code here where you overlay that. Although you might want to think about like the noise that it adds to the plot. So even if you add it, you might want to maybe add this an outline, or maybe like make it just the outline of the states, right? And then make the lines really thin. It's actually a really good idea. So I would strongly recommend, yeah, if you interested, please do it. And if you do it, please share the code with me. We'll be very happy to see how you did it.
Okay, and the next question is from Suravi. Can you explain the argument orient?
Sorry, which argument?
The argument orient.
Orient. Yes. Okay, the orient here. So again, I'm gonna the easiest way for me to do it actually is this. So anytime you have a question about one of these things, right? The easiest way to resolve it is actually to go to the documentation. I'm assuming this is correct. So basically, like this gives you everything. So the orient argument dictionary basically means that it essentially turning it into a dictionary. Records is what I want, because I want a list of dictionaries, and so that's why I chose records. If you do dictionary, then it will basically give you each column will be one element of the dictionary. You can't iterate through it easily, but also a lot of other options like list, series, split, and all that. So whenever you have a question on this, like just look up the documentation. That's the best way to resolve it. Let's take one or two more questions. We're kind of almost at time. We're already 5 minutes over, I think. Yeah, so let's take two more questions and then wrap it up.
Okay, so the next question is from Carrie. How does your data know that @state is the state names?
Okay, so this is basically how this is Pandas magic. So this is the recommended way in Pandas when I refer to a variable. So the @ symbol here basically, I believe, instructs Pandas that this is actually a variable, and so like you need to resolve it before you do anything. How Pandas exactly does it, I have no clue. But yeah, but this is how you refer to variables.
Great. And the next question from Reshma. What does RC params mean basically?
Okay. Again, I'm gonna use the same advice I gave before. So RC params is basically like a way. Matplotlib is super flexible in terms of what it's capable of. So RC params is basically a bunch of parameters that you can set for the figure. And these are global parameters, by the way. I mean, that's why I had to change them here. These are global parameters. Once you set them, like, they carry for the rest of the plot. So if you look at it here, it says a dictionary object, and basically, yeah, it lists like a bunch of them. There are a lot more parameters out here. and for some reason, it's not really listing everything. I'm sure there is documentation like of all the possible parameters out here that you can pull. And I the ones I typically use are the figure.fig size because that's really what lets me set it. You can also do it in the figure call, but I prefer this so that it's kind of global.
Great. So the next question is a workspace related question. How can I export a file from my DataCamp workspace to my local computer?
Great question. So there are two things you can do. One, of course, you can publish. So basically, if you publish this workspace, I mean, yeah, it will the rendered version will show up, so you can share like the completed version with somebody. If you want to get it to your local machine, then you kind of do file and then you download, and this is going to pull the notebook into your local machine, right? This won't pull the data sets. This will only pull the particular notebook. So right now there is no way to. There might be an export as well, export notebook. Yeah, but the export is again for like rendered formats, right? So right now we don't have a way to kind of just get your entire content as a zip file locally. But you can download the notebook using the download menu item. Let's take one last question, Yash, and then yeah, I think.
Okay, so we'll have a more general question as a last question. How do you figure out the steps to plan a visualization?
Great question, and like this is something that I've been trying to codify over like many years. I think, okay, so my my general advice to anybody doing a visualization, like once you know what the visualization is going to look like sketch it out on paper or like just have a good idea. Let's actually look at the baseball one. I did talk about this, but maybe it's worth repeating. It's very important to kind of break it down into layers, right? Rather than looking at it as a full visualization, look at what are the various pieces here. Okay, for example, okay, oh, there is a black line here at the bottom. Okay, that's one thing I need to create. Oh, there is all these points here. Okay, I need to create that. Oh, there is the title here. Okay, or there is the orange line here, right? So think about the components and build it iteratively, build it step by step, right? Same case, for example, in the case of the New York Times visualization, like, I mean, like initially we said, okay, we need the grid. Okay, I need a panel for each state, and we did that. And then we said, okay, I need a line plot for each state. Then we did that. Then we talked about the overlays, and then we didn't get to the full distance, but we did discuss like the plan to get to the visualization. So long story short, I would say the steps are like make sure that you have a sketch. We didn't have a sketch, but we had a visualization in front of us, so like that acted like a sketch. So have a clear sketch, clearly document each of the components. So for example, okay, what am I going to show here, right? Total cases. I'm going to show the name of the state here. I'm going to overlay a rectangle. I'm going to show this here. So clearly document each component, and then figure out how to build each component from scratch using whatever library that you have. You're going to be using. So for example, if I did this with Plotly, I would have used Plotly to create each layer separately. I use Matplotlib, so we did it this way. Okay. Yeah, so I think we should call it a wrap. Yeah, so Yash, you want to kind of do the honors, like summarize and wrap this up.
Sure thing. So yeah, with that being said, we'll move towards the end of the presentation. Thank you, Ramnath, very much for the very detailed and a great presentation. And thank you all the attendees for your participation. We will be organizing more of these presentations in the future, so stay tuned and please let us know if you have any feedback regarding this one. We will post a survey link in the chat, and your feedback will really make a difference for improving the future events that we have and really improve workspace for you. And I promise it'll take very little of your time. So if you haven't already, also feel free to join our DataCamp Global Slack community, and we keep posting new features about Workspace and also events that are going to happen in the future. So with that being said, that rounds up our third Workspace Live Code Along. Thank you again all for attending, and I remind you that this session is recorded, and the link to the recording and the solutions will be posted later on Slack, email, and social media. So yeah, with that being said, I hope all of you have a great rest of your day, afternoon, or evening, wherever you're tuning in from. Yeah, bye-bye.
Thank you. I hope you enjoyed it and have a wonderful day, night, wherever you are. we'll see you soon in our next code along.